Okay guys, in this video segment we're going to talk about solutions and how we can take a concentrated solution and then dilute that down into a less concentrated solution and then the math behind that. So be ready for that coming up here in a day or so. Now if we move on from Beer's Law, I'm talking more about dilution. When you dilute something, what you're doing is you're taking your concentrated solution and you're adding only solvent to it. Okay, so you're not adding any solute and you're not changing your amount of solute. So whatever solute you had before will be the same as you had after. If you take a look at this picture, we have concentrated solution over here, and each glass moving down is more and more diluted. So you see how the different amount of light passed through here, going back to Beer's Law, where this one, very concentrated, isn't going to let much light through. Here, very dilute, is going to let a lot of that solution through. Okay, so imagine like if you had a cup of coffee and it was too strong. Well, what would you do to make it less strong? Well, you just add some water to that. Or if someone made up some Kool-Aid too strong, or if you put too much Mio into your water bottle, you might just add some more water to that to dilute it down a little bit. Now that works fine if you don't really care about concentrations, but if you have to actually calculate the differences, or you're trying to make a very specific concentration solution, you need to go through the equation. Okay, so here's our dilution formula: M1V1 equals M2V2. M1 is the molarity of your concentrated. Sometimes we call this the stock solution. V1 is the concentration of that solution. And then M2 is molarity of your dilute. And V2 is the volume of that dilute. Basically what we're saying is that if you take the concentration times how much is there, that doesn't change with the dilution. So take your new concentration, multiply how much you have, that amount, that ratio would still be the same there, okay, in terms of what these two equal. So what we can do is we can start with a concentrated solution and we can solve for what we're going to make for a dilute solution. Or if we have a dilute solution, we can figure out what we started with as a concentrated solution. So let's go through some practice problems. So problem number 1, concentrated HCl is 12 molar. You want to make 250 milliliters of 3.0 molar HCl. That of word between there reminds you that you're multiplying these two things together, because you have your concentration of a certain amount. So you have 250 milliliters of 3 molar. So what volume of 12 molar do you need? Okay, so you have enough of this, we just need to know how much we want. So we're looking for the V1 here. Okay, we know what our concentration is to start, we know our ending volume and our ending concentration, so now solve for how much HCl you need. Once you have that done, the last step is how much water do you need to add to make it to that. Because you can't just use the concentrate, you actually have to have a volume or amount of water to add to it also. Okay, so go ahead and do the practice calculation, give it a shot, pause the video, and then I'll give you the key here in a second. Okay, so let's take a look at the answer key now. If you take a look, we rearrange our equation. We have our volume solving for our V1. We have our concentration times the volume of the second of the dilute divided by the concentration of your stock solution, and we get 62.5 milliliters of your stock solution. Now that's only half the story. The other half is, well, if you have 62.5 milliliters of the concentrated, how do we get to 250? Well, the total between this plus the water has to equal 250. So for the second part, how do we solve for how much water we use? It's just a subtraction. So take the total you want minus how much stock solution you're going to put in, and that will tell you how much water to add to it. So if you're going to make this up, you would measure out 62.5 milliliters, pour it into a beaker, measure out 187.5 milliliters of water, pour that into the same beaker, stir them up, and you now have made a 3 molar solution from a 12 molar solution. Okay. Notice how, as we look at significant figures, these don't necessarily match what you're making. It comes back to what you have or what you've already measured in there, because these numbers here really are not measured in this process. Dilution 2 practice, a little bit difference with this one. First, we're going to dissolve a certain mass in grams of our copper chloride to make 5 liters. So step 1 isn't diluting. Step 1 is going actually back to last week where we actually made a solution. So step 1 is make a solution called a stock solution. Step 2 is then do the dilution. Okay, so 2 parts to this problem. Go ahead and do those 2 parts, pause the video, and we'll come back in a second. Okay, here we go. So the first part, we need to figure out how how much the concentration is going to be of the solution. So if you take your grams, convert to moles. We have a half a liter, so take your moles divided by that half a liter, and then the concentration of the solution that we made was 4 molar. Okay. Now that's your stock solution, or it's your concentrated. We have a half a liter of it, so if we take that 4 molar, take it times the half liter, divide it by the 0.25 molar, or how much we want to dilute it to, that tells us that we can make 8 liters of this diluted solution. Okay. So if you wanted to make 10 liters, you wouldn't have made enough to start. You'd have to either put more mass in, so you have a stronger or more concentrated stock solution, or you'd have had to use more of your volume with the mass together. Okay. So that is dilution practice number 2.